For my summer thesis, I examined the direct and indirect burden of COVID-19. So to start off with a brief introduction, there has been efforts to track the actual mortality burden of COVID-19 because there is general consensus that the reported numbers may not accurately capture the actual mortality burden of COVID-19. And this is due to a variety of causes, including lack of testing sites, state-level differences, and delay in reporting the deaths. I have three main primary research goals. The first is to use a time series model to more accurately estimate the actual deaths due to COVID-19. The second research goal is to examine the direct and indirect effects of COVID-19. For example, how does social distancing impact the prevalence of other diseases? For example, do people may not go to the doctors as much, and this may cause a higher mortality due to lack of treatment for chronic health conditions such as heart disease and diabetes. The third research goal is to estimate the direct and indirect burden of the COVID-19 pandemic and other parameters, such as cancer, diabetes, heart disease, influenza, etc. The US regions can be divided into three main categories based on how it has been impacted by COVID-19. The first are those that show an early sharp peak, such as New York, New Jersey, Illinois. The second are those that has shown a recent increase, such as Arizona, Florida, and Texas. The third category is those that show a gradual increase, and these include states like Alabama and states in the Midwest. So this is a typical graph for those states that show an early sharp peak, such as New York and New Jersey. As shown, the black line shows the actual mortality numbers for respiratory illnesses and COVID-19. As you can see, there is a very sharp increase after the dotted lines, which represent March 20th. So once the national COVID-19 was declared a national emergency, there is a very sharp increase in the number of cases. The red lines show the predicted values or the fitted values based on pre-pandemic conditions. The green lines show the seasonal baseline. So as could be shown in both cases, there is a very, very sharp increase in the number of respiratory and COVID deaths after the national emergency is declared. The second category are those that show a recent increase. So these include states such as Arizona, as shown here. So as you can see, there is a March 20th line right over here, and there is, for a little while, it does not increase, but then is starting to show a sharp increase recently. And for this, I modeled both the natural spline model and the sine and cosine model, but as can be shown here, the natural spline model was much more flexible, but it didn't accurately capture the seasonal baseline. So I've concluded that the sine and cosine model was much more robust. And this is the third case scenario, which show states in the Midwest and Alabama, they show a much more stable increase. So you can see that the peaks are much more broad. And in the beginning, there was a little bit of problem with reporting delay. So instead, I used a program in which I could backfill and predict the actual numbers of the mortality. So as can be shown here, this is the raw model, raw data, and this is the backfilled model. And I also plotted the incidence, seasonal baseline, and fitted line for a lot of other causes, such as cerebrovascular, cancer, diabetes, and heart disease. And as can be shown, diabetes and heart disease show a very similar sharp peak pattern, similar to that of respiratory and COVID-19 mortality. The next analysis that I did was the x-axis is the date and the y-axis is the correlation in the excess mortality between respiratory COVID with a variety of other causes. So the main parts that you could focus on in these graphs is that as the time progresses and towards the more recent times of the pandemic, there has been a sharper and more clear correlation between COVID with all cause, with diabetes, as you could see by the sharp peak, and heart disease, and influenza and pneumonia. But there is less of a correlation with cancer. So the previous slide showed these in a graph format. This box plot shows which differences in the pre-pandemic correlation and post-pandemic correlation are actually significant. So those that are significant has been marked by red stars. So for example, we see that for a lot of these causes, there is correlation in heart disease with respiratory COVID, as could be shown by the red star here. And if we take a look at, for example, New Jersey, there is correlation between all respiratory and COVID mortality with all-cause cerebrovascular disease, diabetes, heart disease, and influenza. The next part is I also looked at the age distribution of all-cause mortality across different states. So, for example, the important part to note in this diagram is that we can look at the under 25 years. So it's the bottommost line. And there has been a general trend that states in the South have much more mortality in under 25 years compared to states in other regions. So for example, Texas, Florida, those states tend to have a higher young people mortality. So as a brief discussion, there has been much more graphs and much more correlations that I drew, but the general results show that the excess deaths associated with COVID-19 may be significantly higher than is currently being proposed. And for further research, I plan on examining the correlation between mortality incidence and average correlation between each parameter and respiratory COVID during the pandemic period. And for future directions of my research, which I'll continue throughout the year, is I'll expand the analysis to different age groups, counties, and more different mortality causes. Then I'll also examine trends in case fatality. And the third is to improve the model to better estimate the baseline, which will be much more flexible and also robust. So that is the end of my presentation for my summer research.